Here we're going to calculate rate of change when we're given a graph. So first off, let's review. Rate of change is the same as slope. The steeper the line, the more up and down it is, the higher the rate of change, the higher the slope. And in order to find the right rate of change when you're given a graph, you can either do rise over run, if you're able to distinguish the points and count how much you're going up and down, and how much you're going left to right. Or you can use this formula here. So for this graph, since we're using decimals and stuff, I'm just going to use the formula. So I'm going to label, I pick 2 points, I'm going to label my x and my y, and I'll call this x1, y1, and x2, y2. And then you substitute them into the formula. So slope, or rate of change, is the difference between the y's divided by the difference between the x's. Once you substitute them in, you just start to simplify. So let's subtract. And then we can simplify this some more. 3.4 divided by 5 is 0.68. So what is that telling us? 0.68. Notice I already put the dollar sign on there, but let's look at it a little closer. The y is what? That's the cost. So this represents the cost. And the x is the number of muffins. So what this rate is telling us is the cost per muffin. So this is 0.68 or 68 cents per muffin. All right, let's look at another. This one is a little different in that it's not one straight line with the same slope the whole time, but different pieces. The slope in each of these pieces is different. So let's take a closer look. It says the graph below shows Blair's distance from home on a 6-hour train trip. During which of the following time intervals was her average speed in miles per hour the greatest? So the slope represents the speed in miles per hour. Let's look at each of these intervals. What choice A is telling us from time 0 to time 1 is saying time from 0 to 1. So they're talking about this portion of our line. So let's think about and compare that slope to the slope between 3 and 4. Which one of those is greatest, is the steepest? The blue one, right? The slope of a flat line is 0. Now let's look at the next one. Between 4 and 5. So time 4 and 5, this one. What do you think about the blue and the green line? The green line looks steeper. So that slope, that rate is higher. And now let's look at one more, between 5 and 6. Yep, the green one definitely is the steepest. But if you are able to at least narrow it down, you could calculate the slope, like if we wanted to compare the green and the blue one, just to make sure that the green one was higher. Let's do that. So if I look at the green one, you pick 2 points, and I'm just going to estimate, and I'm going to use rise over run. So going from the left point to the right point, how many units am I going up? Well, it looks like we're starting off at about 160, and we're going up to 270. So we went up 110, and we went over 1. So the rate, the slope for that green line is 110. Now let's look at the blue one. We're going between these 2 points. We're going rising about 50 and run again 1 unit. So the slope of that blue line is 50. So that confirms for us that the green portion of the line between time 4 and 5, the slope, the rate of change is highest.